All right, we're going to be looking at 9.1, Area of Parallelograms, starting on page 661. A lot of this is going to be very familiar to what we just did yesterday with the inquiry lab of Area of Parallelograms, but that gave you more of a, an outside the box kind of look at it of how it works, and then this is going to be the basics, okay? So vocabulary startup says a polygon is a closed figure formed by 3 or more straight lines. A parallelogram is a quadrilateral with opposite sides parallel and opposite sides the same length. A rhombus is a parallelogram with 4 equal sides. Fill in the lines in the diagram with polygon, parallelogram, or rhombus and draw an example of each. So go ahead and fill in the lines on how you think that this all works out and draw a picture of each. When you come back, I'll have the answers as well. Pause video now. Alright, and here are my answers. The big circle, which encompasses both parallelogram and rhombus, is the polygon, because parallelograms and rhombuses are both polygons. The next large circle, I have parallelogram, because within parallelogram, it includes rhombus. Okay? It doesn't include all polygons, because a triangle is a polygon, and a triangle is not a parallelogram. So that's why parallelogram's in the middle. And then rhombus is the tiniest one. A rhombus said that all sides had to be the same, and so not all parallelograms are rhombuses. A rhombus is only the one that has all 4 sides equal. Okay? So a triangle is not included in that because it doesn't even have 4 sides. And let's say a rectangle or a parallelogram that's in a rectangular shape, those are not rhombus because rectangles don't have same sides. Alright, so the real world link down here says that expert skateboarders can slide down the railings of stairs safely. A parallelogram is used to build a staircase. How many sets of parallel lines are shown in the parallelogram to the right? And let's get the picture of the parallelogram to the right. Alright, so here's the picture, and it's saying how many sides are parallel in the parallelogram to the right here. Well, we've got the 2 sides here that are the same, and then we have the other 2 sides here which are the same. So to answer the question, how many sets of parallel lines are shown in the parallelogram to the right? There are 2 sets of parallel lines. Alright, so find the area of a parallelogram. The area A of a parallelogram is the product of its base times its height. But notice that when it's talking about the height, it's not talking about this length, that's the slant height. It's actually talking about the actual height, how tall you are. So if you're leaning up against the wall and somebody's measuring to see how tall you are, they're going to see how tall you are to the wall, not your actual full height, because if you're slanted, that's not going to give you your full height. So we're just going to find the actual height, not the leaning height, the slant height, but the actual height. Alright, so it says the area of parallelogram is related to the area of a rectangle, as you discovered in the previous inquiry lab, that if you took this little triangle here and you moved it over here, that you would have this rectangle. Okay, so of course we're going to use the same formula, base times height, where we've got the base, which is this, which is exactly the same. If I were to move this over to here, this distance would be the same. So it's the base times the actual height, not the slant height, but the actual height. So the base of the parallelogram can be any one of its sides, and then the height is perpendicular distance from the base to the top. Okay, perpendicular means that little 90-degree angle there. Parallelograms include special quadrilaterals such as rectangles, squares, and rhombi. Alright, so example number 1 says find the area of the parallelogram. And as you can see, this is on graph paper, so you're able to count the units yourself because you can clearly see what the units are. So if this is going to be our height, then this is our base. So counting our base numbers, we've got 1, 2, 3, 4, 5, 6. So the base is 6, and then the height we can count from where it's a perpendicular line here. 1, 2, 3, 4, 5, 6, 7, 8. So we've got a height of 8 and a base of 6. And so the area formula for a parallelogram is base times height. So we're just going to do 8 times 6. And that is it. And so we find out that the area is 48 square units or units squared. We don't know what the units are. They don't tell us if they're centimeters, meters, but we can't just say 48. That is not the answer. We can write 48 and then units squared. Okay? So number 2 says find the area of the parallelogram. This time they do give us the units of measurement. And so they show us here that the base is 20, the slant is 13, but the height from a perpendicular is 11. So this is where they give us way too much information, and you need to make sure you're using the right pieces. So the height, the base is 20, the height is the 11. So these are the two numbers I'm going to use. This is just extra information I do not need to use. So I'm going to do 11 times 20, 220 square centimeters or centimeters squared. This is how we're going to write it with the cm and then the little 2 up there to show square. That's how we always write our area. So you're going to do A and B on your own. Go ahead and work on those now. And then when you come back, I'll have the answers for you. Pause the video. All right, and here are the answers. Notice that I wrote my formulas each time, and so that's really what I would like for you to do. So please make sure you write your formulas and then fill in your units. And so your answers will be 18 units squared and 64 meters squared. All right, find missing dimensions. A formula is an equation that shows a relationship among certain quantities. To find missing dimensions, use the formula for the area of the parallelogram and replace the variables with the known measurements. Then solve for the equation. So this is basically a one-step equation. Okay, if we know the base and we know the area, like we do here, we know that the base is 9. So for base, we're going to put 9. We know the area is 45. So for area, we're going to put 45. The thing that's unknown is going to be our h value, and so that's what we're solving for. We're basically setting up an equation that will solve for h. So we've got 45 is equal to n times h, or sorry, 9 times h. We would divide both sides by n, sorry, I don't know why I keep saying that, by 9 to get the h by itself, and then we find 45 divided by 9 is 5, and so now we know that the height is 5 inches. So if you want to check your work, all you do is plug in the height that you found, and you say, okay, if it's 9 times 5, that's 45, that's the area, check mark. Checking your work is super easy. So you're going to do C and D on your own. Again, they're giving you the area, and they're giving you one of the dimensions, and you're going to find out the other one, either the base or the height. All right, go ahead and pause the video now. All right, so you should have found that the base for C is going to be 8 meters and that the base for D would be 12 yards. And again, you should always start with your area formula and then plug in what you know and solve. So for example number 4, it says Ramilla is painting a replica of the national flag of Trinidad and Tobago for a research project. Find the area of the black stripe. All right, so the black stripe is shaped like a parallelogram. So use the formula A equals base times height. Okay, so area equals base times height is our formula. And remember, we always start with our formula. Okay, please get used to doing that. I know it seems like an extra thing that you have to write, but it's well worth it to be able to quickly plug in what you need to know. All right, now they're telling us that the we know that the height for this is going to be 12. Okay, so we know the height is 12. That makes this the base, and so the base is 6 3/4. So I'm going to do 6 3/4 times 12. Remember our distributed property where it said that we can separate things? This is one of those occasions where it would work out really nice to do 12 times 6 plus 12 times 3/4. So 6 times 12 is going to be 72. And then when we do our 12 times 3/4, we have 3 here, 1 here, so that ends up being 9. So 3 times 3 is 9 and over 1, so that's going to be 9. So 72 plus 9 equals 81. So you have to reach back in your memory and remember how we used to do distributed property. Otherwise, you can do MAD and make this into a improper fraction and then multiply times 12. That's also an option. So it says height of parallelograms. For the parallelogram formed by the area shaded black in example 4, its height is 12 inches, is labeled on the outside of the parallelogram. So it's all the way over here that you see it. All right. And that finishes up our lesson for 9.1, area of parallelograms. I'll see you in school.